This is tutorial for day one, and in this tutorial we are going to do two things. First of all, I'm going to give you an introduction to setting up and running a Telemac 2D model of Poole Harbour using Pyxis. We're going to use the built-in, the example file that comes with Pyxis. So that's the first part, is setting up and running this model. In the second part, which is just very brief, we will look at how we actually visualize the results of that model using Blue Canoe. So the first step is to set up a new folder. I'm just going to set it up on the desktop here. So I'll set it up on my desktop, and I am going to call that new folder SOES6011 Practical. Now, as far as possible, when you're doing these practicals, try and keep the exact naming conventions. So SOES6011 Practical. Okay, and throughout the 5-day practical, we will create and download files to that to run. Now, in this first practical, we do not need to download any files because they all come as sort of built-in examples. So we're going to work from within this folder. Okay. Now, in terms of the university computers, to find Pyxis, just click on the Start menu and type Pyxis, and it should come up there. I've just, for ease, copied a shortcut to my desktop, which I'll use just because it's a little bit easier than going through the menu each time. So it will take a little bit of time to get Pyxis started for the first time you use it. So we'll just wait for that to load. Okay. So this is our Pyxis window. At the moment it just looks very blank and boring. But what we need to do to start with is the first time you use it, we will create a new workspace. In tutorials 2, 3, 4 and 5 we will open the workspace that we've created today. So this workspace is almost, I guess, a bit like a blank canvas. This is where we're going to store all our files and where we're going to build all of our models. So I'm going to select the SOES6011 Practical folder that I created and go select. And this will create the workspace for us. Okay, so we'll just wait patiently for that to load. Pyxis has been developed by HR Wallingford. It's essentially a way of more efficiently managing and auditing models. I guess it's a bit like a box where numerical models can store, organize, and run their models, and it's a collection of tools as well. And as you'll see later, each model we set up using a predefined workflow. And a workflow is essentially a set of steps that you have to follow to set up your model in terms of loading in the grid first, setting up all the parameters, validating and running our mesh. So we're just waiting for that workspace to create, and you can see it should almost be there. Okay, here we go. We are ready to go now. So up the top you can see our workspace. Okay, so the first thing we do is click on workflows. And what we're going to do today, as I said before, is use we're going to set up a model of Poole Harbour. The difficult work has been done for us already. A mesh has been already produced, which I'll show you in a minute. So if you go click on workflows on the left, go add workflow, and there's a number of built-in examples. It should take you to the HR Wallingford folder. If you go to Pyxis Telemac Workflows, scroll down, there's a folder called Workflows, and we're going to set up a 2D model. There's a workflow here for a 3D. We're just going to set up a workflow, and it's this Telemac 2D 18 HRF file. So we'll open that, and what that will do is that will bring up a number of steps that we need to follow to produce our model. So you can see the steps here. We need to sort of input each of these things. So if I just go for model run, for example, we need to input time steps. Each of these steps here has a little help menu which tell you what the sort of parameters are. You can also type your own notes, which is quite useful if you're running a number of number of simulations. Now what we're going to do is we're going to use we're going to use 3 files, okay? And those files, if you just open your Explorer again, those all lie on the C drive within Program Files, 86, HR Wallingford, Pyxis, Workflows, Telemac 2D, Examples. There's a number of files here. We're just going to use 3. We're going to use a cellophane file with an SEL extension. That's our model mesh. We're going to use a variable friction, and we're going to use this LBF file, which is a liquid boundary file. This contains the data. And what we can do is just have a quick look at those files. What I'm going to do now is open Blue Canoe. Blue Canoe is a pre and post analysis package that you can use it with a number of models, but Telemac is one of the models use it. So in tomorrow's tutorial we'll actually build our own grids. This is where you can sort of build the grids and things to run your model, but then you can also look at the results as well. So what I'm going to do is just click on the Open menu and navigate to that folder which contained those datasets. So C drive, Program Files, 86, HR Wallingford, Pyxis, Workflows, Telemac 2D, Examples. And what we're going to have a look at is this Geo Poole Harbour Poole01.cellophane, and open that up. That is opened up, and we'll look at this again when we come to looking at results, but there's a parameter here called bottom. We can just drag that to the 2D view, and this shows us our grid. So this is the grid that's already been set up for us, and we're going to use. We're going to have a boundary on this side, on the west, a boundary on the east. We're going to drive that with tidal levels. We're going to assume there's no flow along this boundary, and that works out quite well because most of the dominant flow in this region travels in that direction anyway. You can zoom in and have a look at the look at the mesh. You can see the deep channel coming through there. Okay, so we've cheated today by using a mesh that's already been generated. Tomorrow we will actually build our own mesh. So that's the mesh file we're going to use. Okay. So the first thing we do is load in that mesh. So click on your cellophane source. So the cellophane is the mesh file, and we are going to go add. And we are going to add our cellophane layer. Go to this examples, it should have opened that forward, and we'll start with the 01, which is a more coarse mesh. When this window pops open, we're going to go use the default, which is parameter points, and press OK. Now the next thing we need to do is set up the projections. So we're going to click on Use Select Transform, go to the 3 dots here, and we are going to use projections National Grid. So go to the drop down menu here and go down to National Grids, and then we are going to use British National Grid. So the British National Grid OSGB 36. Click OK. Okay, and that's our projection. That's the projection in which we've created the mesh. Now I'm just going to enlarge this window a bit, and I'm going to zoom into this boundary. Okay, so now that we've loaded in our mesh, we need to tell the model where our boundary condition is. This is how we're going to actually drive the model. So we need to select this as our west boundary. So you click on this icon here, and we need to click twice. We'll click up the top and the bottom. So you need to click 2 points. We'll go to Add Boundary, and we'll specify this as imposed elevation. We're going to drive it with tidal elevation levels. Okay, so that's our first boundary, and I'll come back to that in a minute to set up. We'll click back on here. I'm just going to zoom out and navigate to the other boundary, and we'll set this one up next. Okay, we need to deselect all the points. We selected it earlier. Choose the selection tool again. Click on the top and then the bottom points. Go Add Boundary. Again, we're going to choose the elevation here and press OK. So if we go back to here, what you can see is we've selected two boundaries, a a west, and a east. Now we're going to go into the west boundary first, and we're going to use a boundary file that's already been set up for us. So I'll just go back to my window here, and LBF here stands for liquid boundary file. Now this is just an ASCII file, so you can open it in any text editor. Right click and go open. On most machines there'll be default text editors. I prefer to use a one called TextPad. And what you can see here is there's some headers, but we've got three main columns. We've got time in seconds, 0, 100, 120, 1,200 seconds later. We've got three columns, sea level 1, 2 and 3. Now because the west boundary is quite small, we'll just drive it with one water level, whereas the east boundary will drive with two water levels, one from either end. Okay. So what we'll do is keep the first thing as uniform. We're going to drive it from a file, select the file there, and press open. Okay. And we're just going to keep this simple. We will use the first sea level boundary condition. So it's uniform, so that single sea level will be applied uniformly across that boundary. We're going to go on to our next boundary, and this one we're going to do a little bit differently, but we're going to drive it with two sea levels, sea level 2 and 1 from that file. So select the file again, and the top, so the northernmost point, we will drive with the time series in sea level 2. We're going to add a new line, and this we're going to put interpolated. Select the file again, and this one is now going to be number 3. And the normalized length, so the north is going to be 0, this is going to be 100%. So the northern boundary will be driven with sea level 2, the northern part of the boundary, the southern part will be sea level 3, and it will linearly interpolate that between. Okay, so that's the first stage, is loading in the grid and setting up your boundaries. Now we need to set up the rest of the model. So the first thing we need to do is set up the model runtime. So this is when our model is going to start and how long it is going to run for. Now this obviously needs to be consistent with our liquid boundary file. So if we just load in our liquid boundary file again, the data actually starts on the 25th of May 2010 at midnight. So that's when we're going to start our model. If we started it before that, then we wouldn't be able to run our model when we set it up. We would get errors. So the 25th of May 2010, and we're going to set our time step up as 10 seconds. So every 10 seconds the computer is going to do a calculation. We're going to run it for a day, just one day. So we need to specify the number of time steps. Now in a minute there will be 60 time steps, because each time step is 10. 60 times 6 times 60 times 24 works out as 8,640. So that's going to run our model for a day. So those are the parameters there, and as I said before, you can write some notes here, or you can use the help menu as well. So that's our run times. 10-second time step, we're going to run it for a day. The next thing we do is initial conditions. So this is what the water level is going to be. We're just going to use a uniform elevation. So what we're going to do is we're going to put it in as 2 meters. So when the model starts, it will be 2 meters everywhere. And the reason why I've done that is if you go back to your liquid boundary file, you can see that towards the start of the run, the water level is 2 meters. So by putting the water level of the model around what the boundary is, it means that the model will hopefully have a fairly smooth start. If you set it as -2, there would be an initial jump where the model's trying to get rid of lots of water. Next we go on to our physical parameters, and this is where we set up things like the friction, viscosity and Coriolis. So friction is the bed friction, how much that the model's going to feel that. We're actually going to use a varying friction map. You can specify uniform and just put in one value. We're going to go with the default friction law here. There's various others available, like the Manning law, which we will use later on. But to start with, we'll just go with the default, specify spatially varying, and if it's spatially varying, we need to define a file. And what we're going to do is use this friction map already created for us. So that friction map is the same as a grid, but rather than having depth, its values are values of friction that will be in the order of these sorts of values that you've seen here. Again, you can use the help menu to sort of tell you what the different options are. We're going to use the viscosity, almost the sort of thickness of the water as default, and we're going to include Coriolis as well, so we need to give a representative latitude. So this part of the world, our latitude is 50 degrees, point about 6, 8. Okay, so that's our physical parameters set up there. In terms of numerical parameters, this is the actual sort of equations that are used to solve the hydrodynamics. We're going to keep all of these as default. We're just going to include the tidal flats option here, and this means that because we've got shallow areas that will dry out, it means that the model is able to dry those areas out. We're going to include the tidal flats there and leave everything else as default. Now we choose what we want to save. So these are all of the things that we can save to our result file, but we'll just save the U and V velocity, the water depth, the free surface elevation, so that'll be the tide, and we'll save the bottom elevation as well. That's what you get from your original grid. So we'll just leave those as defaults, but if you want other options, you can include them there. Now this is where we determine how often we want our results files saved. So what I'm going to do is our time steps are 10 seconds. So if I set that as 90, it's going to save the results every 15 minutes. We don't need to save the results every 10 seconds. Our results file will be too huge. We're just going to save the results every 10 seconds, and we're going to write a log file as well every 10 seconds. This just, if the model crashes for any reason, that log sort of records that information. So we've done the first main stage now, which is to set up the model. And it's always good just to save this at regular time steps. Now that we've saved our model, now that we've set up our model, the next stage is to actually validate it. So we're going to go back to build this on the left, build and run. And what we need to do is give this a title. I'm going to call it capital Poole Harbour, and for the caption, I'll put the caption in as the same thing. Now what we do is click on run and validate, and this just makes sure that we've set our model up correctly. If we had set up our model, if we had done something wrong, then we would have some errors. So this says the caption, a run caption must be specified. We have got a caption there, so let's just run that again. So now you can see we've got no errors. If you set up the wrong time, if you put in the wrong time for your boundary files, etc., that would tell you there. Okay. So now that we've got everything set up, the second step. So the second step is to run the model. So click on run and run locally. And this will do a number of things. First of all, it will build the model. The model is Telemac runs in Fortran, which is a software programming language a bit like MATLAB. So it will compile the code into Fortran, then it will go away and run it. This is a relatively coarse model, so it should run quite quickly. And what you can see is it's processing. If we click on refresh, go down to the bottom, we can see that it's already got to time step 1700. So it's doing really well. We can refresh again and just keep track of where it's got to. It's already got a quarter of the way through. So we'll just wait a minute and let that finish. It shouldn't take too long now. Let's have another look. Yeah, more than halfway through now. So not long at all. When we run other models, if you run very, very detailed fine resolution meshes, it could take several hours, if not several days sometimes to run. In fact, the very, very high resolution models could take up to a week to run, but this is a quick one, probably just a couple of minutes. I think we're almost done now. So it's complete now. So what we can do is just save that, minimize the window, and what we'll do now is we'll go back and look at the practical file. In there's a folder called Runs, Poole Harbour, and what we're looking for is this res file here, this results file. So that's where all of our results are saved. So just in the last couple of minutes, what we're going to do is open Blue Canoe. And remember, I opened it earlier and showed you the mesh. Well, what we're going to do now is I'm just going to right click and remove that. What we're going to do is open that results file now. So we'll go to our practical folder, Runs, Poole Harbour, select Res and open. And this will open all of the results. And what you can see is, as we selected in the model, we wanted the velocity, water depth, free surface and bottom. But what we can do is drag the velocity UV into the 2D view, right click on it and go animate. And what we can do is step through a couple of sessions. In fact, what I'll do is I'll just play it here when it's caught up. And what you can see, those are our model predicted flow patterns now. It's running a bit slow because I've got a number of things going on my machine, but what you can see is the water's coming in on the west boundary. As I said to you before, the flow quite nicely follows that boundary anyway. And over the next few days, we'll look at how to do many more sort of sophisticated things in Blue Canoe. So you can see that currents are speeding up here. We're probably getting into flood. At the moment, there's not a lot happening in Poole Harbour, but as you run through further and further, you'll see that more will happen. So I'll just stop that and we just go to the end. Yeah, you can see now we're on the ebb tide. So that is the end of tutorial 1. What I'd encourage you to do is go back to Pyxis, look at changing some of these parameters and seeing what happens, run the model again. Alternatively, go back to your example files and try and set it up using the higher resolution mesh. So we use mesh 1, try and use mesh 2 instead.